Yeah, okay. Hi everyone, I'm Dmytro, also Dimi. I work at HomeGate as software engineer in one of the teams, which is responsible for search alert systems, basically the thing that you can create when you search for an object of your interest in, like, that satisfies your criteria. And you can create a subscription that will send you either by push notifications or by email all the new listings that we're getting published on the platform. So, and I'm going to talk about our experience of using AWS Elasticsearch Flavor, so the service that provided by Amazon, and all the experience and all the hurdles and pitfalls that we met while working on it. So our primary, or like only use cases for now for the Elasticsearch at HomeGate is the system dimension search alert, where we use it for two cases. The first case is how we implement search. Basically, when a new listing comes in, we try to match it amongst all the search subscriptions that we have using Percolate. And the second use case is we're sending all the analytics events that are happening in search alert system to Elasticsearch cluster just to do some all-up on it. And Amazon provides you like a very easy and quick way to start using Elasticsearch, and they have several ways of you setting it up. But the problem is it has lots of limitations, or like several limitations. Like we try at HomeGate to do our infrastructure as code, and one of the main approach from Amazon to implement your infrastructure as code is by using CloudFormation service. CloudFormation service, for those who you don't know, I'll quickly skip to the next slide, is a system where you declare your infrastructure in a declarative way, and then it has a state. So it keeps, every time you make a deployment, it creates a state, and then when you make a new deployment, it tries to detect a change set and apply it. The problem is that it's just another system in Amazon, so it uses internal APIs, and sometimes it's behind what's available at Amazon. And with Elasticsearch, it's exactly the case. So, for example, when you configure a cluster, you can choose, for Elasticsearch, you can choose a smaller subset of instance types, which is comparing to what's available on AWS in general. And usually those which you cannot use are the newer ones, which means cheaper and probably more efficient. Sometimes they're also, like for example, those P3, P2, G3, those are GPU instances which don't make sense like for now in Elasticsearch world, because Elasticsearch currently, even for machine learning, doesn't use GPU acceleration as far as I know. But some of them, like those T3 or like newer generation instance types, it would totally make sense to use them because it would save costs. When you use Elasticsearch and AWS, it's basically a managed service, but it's not really close. Like if you try to implement everything in a serverless way, it's not really a serverless thing because you allocate fixed resources. It doesn't support auto-scaling, even though EC2 itself, like the underlying service that Amazon uses to run Elasticsearch, supports auto-scaling group. Elasticsearch and Amazon does not support it, so you basically have to manage the cluster yourself. And the problem that I mentioned before with CloudFormation is that if you apply too many changes, like when you update your infrastructure, let's say you want to change at the same time instance type and volume size, CloudFormation will either not allow to do it or will trigger a cluster replacement, which means you will lose your data if you didn't create like a snap. I mean, they have functionality to create automatic snapshots of your indexes, and you would be able to, in this case, ask support team to restore your indexes on a new domain, which means a new instance of a new cluster. And it doesn't allow you to basically reuse the newly created with new configuration cluster. Another limitation that we faced, and what was really annoying, is that when you try to upgrade versions, cluster will get replaced. So what's your workaround for it. You basically want to create a new cluster and then try to reindex the data from the cluster you have already. Then you would be able to switch the endpoint in the application and continue using new cluster. But the problem is that you don't have access to cluster settings on AWS. So you cannot change cluster parameters through native way of configuring cluster in Elasticsearch. You don't have access to YAML file, obviously, and you also don't have access to API, which means you would have, if you really need to change configuration of your cluster, you have to choose a configuration which allocates double the resources at least. Then you restore, or like if it's migrated successfully, then you're lucky. You have your index, and then you try to reindex with a different configuration because you want to benefit from the new improvements, like software improvements in the new version, to get the data in a more optimal way in a new version of the index. And then you have to downscale again. So this kind of things that could be really annoying when you exploit a cluster in your application. Plugins. There are lots of plugins in Elasticsearch, but you have no way of changing what you have in AWS. So you have a predefined list of analyzers and other plugins. You can just look at the list and you cannot do anything about it. So you cannot install any more, and you cannot even if you have like enterprise level of support, you will not be able to change the configuration of a cluster in this regard. Access control. As you don't have any plugins, you don't have licenses from Elastic, so you cannot have XPack, which provides like the natural way of access control in audit and user management. The only way you have to limit access to your cluster in AWS is by using IAM policies, which is AWS Service for Identity and Access Management. And those policies have basically split into two groups. It's like resource or identity-based policies, and if you use them to access it, you would have to sign every HTTP request when it's sent to Elasticsearch. Or the other way around, you would have to use IP-based policies, which restrict you to only those actions based on HTTP methods. So, for example, with the problem that we face in this regard is if you want to use Kibana but restrict write access to your index, you're in trouble because Kibana uses not just GET methods to access Elasticsearch. So you will not be able to have a fully functional Kibana and read-only access to the index. As this like a quasi, I mean, Elasticsearch is open source, we all know it, but the instances that you get running in AWS, they have proprietary software. So sometimes they redact responses from the API, or if you, for example, look at the hot threads, you will see that some of the classes disappear from the stack tray, so you will not be able to see exactly what happened in between. And the management tools that they provide for basically having some kind of observability about what's happening in your cluster, they also sometimes puzzling. As you can see, for example, for this example, it's exactly at the same moment I'm looking at the dashboard in AWS to see the state of my data instances, and the available disk space is very different from what Elasticsearch itself replies to me. I guess they kind of consider some watermarks, but it's not really documented. So you will get alerts about low disk space much earlier than it's actually a problem. You will never, whenever you receive an alert and then you check a static cluster status and it's still green, it's all fine. So you get confused quite often. The IAM identity management service that is in front of your Elasticsearch in AWS, it introduces some kind of sometimes unpredictable behavior because they have internally hard-coded configuration settings for a cluster, which depends on instance types, and sometimes you will hit the limits of IAM before you would hit the limits of the capacity of your cluster. For example, we are facing on our analytics cluster where we just store, it's mostly like write-only and some all-up stuff on top, write-only cluster. It's about not really big, it's like 4 nodes, so M3 medium. and we sometimes hit up to 2% of failures from IAM. So before it reaches even Elasticsearch itself, you will get basically connection failure before it even the request reaches Elasticsearch, which means it's something that you cannot do much about it. And what supports recommend you is to basically scale your cluster if you don't even need more capacity from Elasticsearch itself. And again, this kind of hard-coded configuration is not documented in anywhere on the website. Other limitations, like you would have EBS volume snapshots only at most once a day. There's no support for native Elasticsearch protocol, so you only have access to it for HTTP. You'd probably only feel it when you want to migrate a lot of data, but still, it's quite annoying. A few APIs like index, open, and close API is not available to you. So if you want to use other APIs that require it, like shrink API, for example, to optimize your index, you will not be able to use it. There's no Elastic APM available. There will never be like Elastic machine learning available. No SIEM. Basically, you will be using a special version of Elasticsearch in AWS for a long time. Another thing that's very annoying is the delay with which you get newer version of Elasticsearch. The latest update was in August. They got 7.1, and it's 7.3 available. So there is no version downgrade. As a workaround, they suggest you, as I mentioned before, they suggest you, if you didn't like the new version, for example, when we were a bit rushing, and we went for 6.1 for properly testing our code, so we had to go back. And the only way to go back would be to either start a new cluster, or they would restore the snapshot from the snapshot repositories that they have managed, a new cluster. So you cannot, you will have to reconfigure your application anyway. And there is also a hard limit on the time that the maximum time that your request can run. It's 60 seconds, and it's not because of Elasticsearch. It's because of this proxy/load balancer in front of Elasticsearch. So something that you would, if you use it for all app tasks, you would not like it. So yeah, that was basically my short rant about our experience, and we're considering moving forward to maybe other cloud providers. As you can see, like it was easy to start. We we were moving really fast with the engineering, so we didn't really spend much time in like investigating all options in deep details. We just had to move. So we started with AWS, but now we're looking to other options as well. Thank you very much, and thank you to my wife for helping me with the slides.